Okay, everybody, we're going to talk about a problem which is related to um, problem 1-3 of your homework, and it's also on the vector sheet. And I started by introducing some of the key items here. Um, what we need to understand is that there are 3 point charges that all have a charge of q, and whatever q is. And they're located about they are located at the same distance from the origin, but a different place in space. So, for example, the one I've labeled number 2 is 0 in the x-axis, -1 in the y, and 2 in z. But since I don't have three-dimensional graph paper, I can't plot where point 2 is. And if you look at point 4, I can't plot where it is either. But I can plot where point 3 is, and I've done that here by using the red marker right there. And I've placed that. What we're interested in doing is seeing the influence of this point charge on something that's the origin. Well, by the principle of superposition, we know that that force that's on that one that's in the center here is going to be the sum of the forces due to particle 2 on 1, particle 3 on 1, and particle 4 on 1. It's particle 3, as you recall, that we have plotted here. We can write down the basic Coulomb's law. That isn't hard. That's just, for example, this is one out of the book. Force of 2, and that's the diagram we have over here on the right, due to 1, in other words, the force that 1 gives to 2, is written by this equation here, where we have k electric, the product of the two q's, and we divide it by r squared. And the direction is determined by the hat vector r12. Now, I'm going to simplify this in a certain way, because when it gets time to do computations, we would have to do this anyway. So over here, I have written a formula that's the same as before, but I've written out what r hat 12 is, and you'll see that it is also given here on the right. R hat 12 is equal to r vector 12 divided by r12. You could do a dot product and see that the value of this fraction has got to be 1, so that's a unit vector, and its direction is determined entirely by the direction that r12 points. But what direction does r12 point? That's one of the key things we want to find out. And the way you do that, the way you draw a vector, is you say, okay, a vector goes from an initial point to a final point. In this case, the one I've drawn up here, the initial point is labeled 1, and the final point is labeled 2. And we're trying to find out how 1 influences 2. This is not the same as the problem we're doing. We're developing the apparatus so that we know that how we point our vectors is going to work out well. So to get r12, we would have to take the position for r2, that's our final position, and we would subtract from that r1, our initial position. And that would give us a vector that points like this one does to the upper right hand corner. Well, that's all well and fine, and we can define the r vector r12, but at a certain point we need to turn to our problem. And you can see that I have up here, I've written down this little vector to the going to the lower left, and that vector is vector r. You can see that it comes from the red dot down to the blue dot. The red dot is 3 and the blue dot is 1. So that vector is going to be F31. But let me show them all to you in a second here. Okay, so here is the value for R for force 3-1, written out in terms of K electric Q1, Q3. And you'll see that what we did in going from a step like the one above, where we had 1 over r squared, but we had defined the hat vector in terms of r vector over r, we've combined the two r's, the two denominators, r squared and r together, to get r cubed. You'll notice the units of this are still 1 over r squared, but it makes it easier for us, as we'll see in a minute. Okay, well, what is the value for R31? Well, we're going to start at the final place, which is 1, 2, 0, and subtract from it the initial place 0, 0. So let me do that right now. Alright, I'm going to start this back up again, and I hope I said the right thing, because what I want to say is this. It's always true, to get a vector, you start with the final point, because it's like delta. It's a change from one place to another. So you start at the final point, which in our case is 0, 0, 0. That's the point at the origin that's being acted on. And then we subtract from that the coordinates for the initial point. So that's 1 in the x direction, 2 in the y direction, and 0 in the z direction. So we're going to subtract them like this. I've written them down in the vector form that involves commas and suppresses the I, j, and k. Well, when you do that subtraction, you end up with a vector that's minus 1 in the x direction, minus 2 in the y, and 0 in the k direction. And that's going to be equal to R31. And you'll see up here that I've drawn it already. It points to the third quadrant, and you can see that it points down minus 1 in the x direction, that's this way over here, and minus 2 in the y direction, and nothing in the z. Okay, so I'm going to go ahead and write our x and our y up there. We should have done this a long time ago. So that is, in fact, the vector that is R31. Its magnitude is the square root of 5, as you'll be able to show yourself. So I can now write down all of the 3 vectors that go into forming F1 up here. I'm going to write down them as a series and just say, well, we're going to add them all up. Okay, we're back on. So we can see that we can write R3 equals R sub 2, 1 equals R sub 4, 1. They're all equal to the square root of 5, and we can just call that distance R. That means that if we sum all of these guys up here, we can get that the force on 1 is equal to K electric Q1 over R cubed times this quantity, which involves the product of one of the charges and the vector that takes its influence to the point at the origin. And since all those Q's are the same, we can just take them out as well, and it leaves us just with a sum of 3 R distances. And we're going to do something with that right now. Okay, and I've now summed up those 4 things and written them here in red. So the sum of the r's in the numerator is just 1 minus 1 minus 1. Well, what we want is not just the direction of the force at the origin. We also want its magnitude. So we're going to use Pythagorean theorem to sum all those things up, and we'll substitute in for the numbers that we have as well. Okay, so I've now substituted in for those values, and I get that the force, which is going to be K electric, the product of the two Q's, it doesn't matter that one's minus and one's plus, we'll use the absolute value, over that distance cubed, which is square root of 5, times by our Pythagorean theorem to the 1/2. I need to put a 1/2 right in here right now, so I probably will do that. And there you see that I've put the 1/2 in because of Pythagorean theorem. I knew it was there, and in the next step, when we write that out, we have the square root of 3. Well, let's substitute in for things that we know, and one of those is K electric, 9 times 10 to the 9th. Both the Q's are the same in magnitude, so we have that as Q squared. And then we have that our last term has the square root of 3 in the numerator and square root of 5. That's cubed, so it's 125 in the denominator. The denominator. So we could plug in for our values of Q and see if we get the right force in the homework problem, which is probably true. I haven't done it yet, though. Okay, I went off and did the calculation for my numbers, and when I plugged them into the computer, it told me I had the right magnitude. As for the angle, well, we'll talk about how to do that later, but if you remember our scalar product, that's what you want to do. You want to define one of the vectors being the axis and the other vector being this angle, which involves ones and minus ones that I've written about right here. That's going to define one of the vectors. And then the axis is the other. And we'll end up with a arc cosine of something like minus a third the square root of 3, or you could have it as arc cosine of 1/3 square root of 3. But that's what I did from memory. You'll see yourself if that's right or not as you do the calculation.